Recursion.
The last unit. We only have 2 days of notes on this, today and Friday, and then we've learned all the new material for the entire year, and then we're just going to practice, become better at what we're doing, and so we've almost made it here. So unit 10 is about recursion, and recursion is when a method calls itself. And I wrote on here, it might sound like a bad idea, like, is that really okay? But there are some interesting problems where that makes it simpler to do. So one thing that's true is anything you can do with recursion, you can just do with loops and not recursion, and vice versa. It's not like the only way you can do these things, but here's the deal. Recursion, it's recursion if a method has one or more calls to itself, and then it also needs to have a base case. That's something that lets it quit looping forever. Thanks. So here we go. Here's an example. You guys know what factorial is? Like 5 factorial means 5 times 4 times 3 times 2 times 1. So this is a recursive method that does factorial. So public static int factorial int n, we're sending over a number, and it checks. If n is equal to 0, we return 1. Otherwise, we return the number times calling itself with one lower number. Yeah. Oh. Oh, I see. So the base case here, well, this is the call to itself. Return the number times the same method, but with a smaller number. And the call to itself has to be different in some way. Otherwise, it would go on forever. And then this is, we call the base case. The base case, hey, if it's 0, then we just return 1. And I'm going to walk you through it. Calling factorial 4 causes the following to happen. So factorial 4. 4 is not equal to 0, so it calls 4 times factorial 3. 3 is not equal to 0, so it calls 3 times factorial 2. And so on. 2 is not equal to 0. 1 is not equal to 0, so it calls 1 times factorial 0. And then finally, it calls factorial 0. And 0 is 0, so it returns 1. So basically, factorial 0 becomes 1. So we're basically doing 1 times 1. And then that goes up here, and we're doing 2 times 1. And then that goes up here, and it's a 3 times 2. So 6 goes up to here. Anyway, it's kind of complicated. Here's another one. This one's just called recurs with a number. It prints the number in a space. And then if the number is greater than 0, it calls itself again with a number 2 lower. So let's see what this might do if we called it with 5. We call it with 5, it prints a 5. And then it calls recurse 3, which prints a 3. And then calls it with recurse 1. Prints a 1. And 1 is still greater than 0, so it calls itself again. I had to make those smaller so I could do it. It prints a negative 1, and now negative 1 is not greater than 0, so it stops calling itself, and everything's over. So it's kind of silly, but it is something. Questions? Comments? Yes?
So when Java goes through and that method and compiles the method, right? Like without actually plugging it into it.
Yeah.
Does it run like it's calling itself?
Yeah.
So is Java compiling it itself?
It's just ready to call itself. It doesn't like loop it all out.
Okay.
Like it doesn't know how many times it's going to run, so it's just going to have it there ready, and it sets it up in memory. You can write these things where they crash, where they loop forever and then blow up. Because well, you could make the base case be a faulty base case so that it never would show up, and Java might say, well, I don't know what they're doing with this thing. I'll give it a try, and then boom, And But we could do the greater than 0 one, and we could do recurse n plus 2. And Java's not going to say, hey, I see a flaw in your logic. This is never going to get, it'll blow up. So that's okay. Nothing's perfect. What? If you go one direction real hard, bad things are going to it'll stop at some point. Here's another one, everybody. The Fibonacci sequence of numbers. Do you remember? Have you learned that? It goes 1, 1, 2, 3, 5, 8, 13. You find each element by adding the prior two. But you do start with a 1 and a 1. So this one gives you the Fibonacci, the nth Fibonacci. So I could say I want the third Fibonacci. You send a 3 in, and then it calls Fibonacci 2 plus Fibonacci 1, which calls it 2 more times. And if you ever end up with a 2 or a 1, it returns 1. And it has kind of a double base case. If it's 1 or 2, then it returns 1. So I think I have a picture for this one. And in case it's not clear, we're saying which, give me the fifth. If I send 5 over, I'm saying I want the fifth Fibonacci term in the sequence, which happens to be 5, but there's no guarantee. So the second term is a 1, the first term is a 1, the third term is 2, fourth term is 3, fifth term is 5. And here's what's actually happening. I mean, somebody made me draw this out last year, so I'm showing it to you again. You call Fibonacci 5, it sets up Fibonacci 4 plus Fibonacci 3, and then 4 sets up 3 plus 2, and so on. It's just this long chain, and then they all end up, sooner or later, they end up at 1, and they all get added together, and they make 5. So it's kind of magic. Here's another example. Sometimes things run sort of backwards. This one, countdown, you send over a number, it's going to give you the numbers each on its own line going down to 0. That's okay. That's not very backwards. This one, though, you might think it's the same. We're sending over a number. As long as it's greater than 0, we're going to keep calling the number and we're going to print them. But because the print call is after the recursive call, this one goes in the reverse order. So none of the printing happens until it hits the base case, and then it goes backwards. So I can't remember if I do show this one. We call countdown 5. 5 is greater than 0, so we call countdown 4. Nothing's printed yet. And we call countdown 3, countdown 2, countdown 1, and then countdown 0. Now, because 0 is not greater than 0, there's no more recursion, and then the printing is going to start, but it's going to go backwards from the most recent to the first. So then it prints out a 0, and then a 1, and a 2, and a 3, and a 4, and a 5.
So does it run a continue, but what's it can't run the continue anymore? Does it then backtrack? It kind of there's a term that I can't really explain to you, but it's part of computing. It's called the stack, and it's where they store values that they're doing calculations with. And you've heard Stack Overflow. That's a site where people before AI, people would get answers to programming problems. But in this case, the stuff's stored somewhere, and the way it works is it just goes backwards. So one way to think of it, a good idea is to trace these things on paper, write down things. But in terms of the forward versus backwards question, in general, if the print call comes before the recursive call, it's going to happen in the forwards order, like in the order that it's happening. And if the print call is after the recursive call, then it tends to go backwards. And there's no single rule. I can't tell you it's always this or always that. Any questions? All right, so your assignment now is to do the first 6 recursion problems on CodingBat. Recursion 1. Don't forget to log in, or you won't get credit.